this is a part of a bigger project with the scope of, and then you start with all of the innovation and problems that Antonio has in his PhD.
Okay, that sounds great actually. But so Antonio needs his project by the end of this semester,
Mm-hmm.
or like maybe by the end of March or mid-April, sometime soon enough.
Yeah.
We tried pivoting off of his project due to the lack of time. Like we need a project and a scope statement of work by Friday. We tried to pivot, but as I told you, this is abundantly available. So is that all right? Is that fine to do as a capstone project? Would it be acceptable?
Well, yes, it might. I mean, once it's commercially available, then of course you are. This is not an open research project at all. However, if you are able to perform some modifications or custom, like proper design a custom project, uh, then you're fine. As long as you're able to customize what you are getting and then adapt it to the solution that he requires, then you should be fine. Of course, the initial requirement of Antonio of a detector that actually works for speech. My understanding is that you have there two 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 paths. The first one might be this is just the first step. You still need to proper develop a further solution. So this is just like the first step. Like he told you this some weeks ago, expecting that to be done in like 3 or 2 weeks, and after that, more instructions will come. The other is that you might build a voice detector that actually performs better than the competition. I just saw the plot that Bradley put on the Slack, and it seems that the probability is actually very high. I mean, there is no much difference between the probability of like no speech versus a speech. So in that case, for example, I would say that as long as the current methods are actually failing, then you might have a chance. Also, my understanding is that the audios where Antonio is actually working, those are audios. Those are very noisy audios with a lot of crosstalk. Uh, are you guys familiar with that?
Yeah, Tony gave us some files like Liz sample 1 and Liz sample 2, and they're directly out of the classroom. They're a
Mm-hmm.
teacher and a student talking with, as you say, there's a ton of noise in the background. So, I mean, we ran that through the detector voice activity, and we got something out of it. But honest to gosh, we just got that VAD example. I mean, Kong and I had a good look at it. And we go, what is wrong? What is wrong? And we got that to work this morning. And so, you know, we just need further instructions, whatever guidance on how to segment or whatever. And we could run these files on these two programs.
No,
So
let me say something. I just saw in Discord that you guys have published some stuff in there, and I saw it, and that's basically what I was expecting. I saw a file in which you got the HAL, the computer talking, and there was some detection on noise and detection on the speech, but it's not perfect. But that's the starting point. That's what I want. You see, there is a bunch of lines that indicate that there is like a silence and speech, silence and speech. That's what the improvement has to come, because we obviously know that it's noise, but it's just the program is hesitating to choose from one to the other, and that's the smart that I'm looking for. Being a little bit, it doesn't need to be perfect, but that's the starting point. That's what I'm looking for. Simple.
May I
can I share my
ask?
screen? Can I share my screen? Can you
Sure,
allow
you can. Yes.
Ahmed?
Yeah, well,
Okay. Here's what Tony's talking about. Right here. This is the detect voice activity program.
Uh-huh.
And I think this is the end of the HAL audio. And so you get, Dave and Hal and whatever, speaking here, then you get some noise above it. And then we have this other one. This
Yes.
is from the VAD.
Yeah. Hmm.
that we ran successfully today. And I
Uh-huh.
tell you, it was just typical MATLAB dumb things that, why didn't we figure this out? But we did. Okay. Tom and I did.
Mhm.
And I mean, this is a little bit different. These have very tall yellow spikes and some voice here, but, maybe Tony can elaborate on that.
Um,
And then let me show you this. We got
Okay.
these text files. This is what we were missing last time. And you can see we got a bunch of ones here. That means somebody's talking. Whoop, they're not talking. One. A little bit of talk, no talk, more talk. And so
Bradley, I have a question. What is the time period for each of those digits?
yeah, what is the time period for each of those digits? That's a good question.
Okay, I mean, it's okay. I'm just asking. We can talk about this later. I do have another question for Tony. I know that your time is limited and we have to do good use of this. Tony, is the voice detector the final deliverable that you are expecting?
I was expecting another deliverable, but let's put it that this is the final deliverable. Yes.
Okay.
Okay.
I have another question then. My understanding is that once you run a Olme in the commercially available voice detectors, those are going to fail. Am I right?
Yeah. There is something that I don't want to confuse the voice activity detector with speaker identification or voice recognition, anything like that.
Yes, of course.
Yeah, it's two different.
Yeah.
The voice activity detection, the only thing that it does is just take a segment, see if it is a speech, and then get that segment as a speech or noise. It doesn't know who's talking. I have no idea.
Yeah, of course. I mean, it's just like the speech on the frequencies where the human voice are there, and then, of course, my understanding is that will allow you to do a pre-processing to clean the audios and help you in your pipeline of process.
Correct. So I'm not looking for something that fails. I'm looking for something that it's a little bit that is better than anything else. It's not
I understand. Do you already have tried any off-the-shelf solution that we can use as a baseline to compare?
No, because my problem is that I do not have the time to do this kind of stuff.
I see. Yeah, makes sense.
Yes, so I can go on.
It's an easy thing to.
Yeah.
I mean, yeah, makes sense. Okay, so then we're like kind of open to develop our baseline and then use that. I understand with our audios, and that's our final goal to produce a voice detector that works slightly better, or at least better than most of the solutions with the audios, or at least find it if you are not going to modify it.
Correct. Fine tuning. You can take those examples. You can fine tune those examples to work better on the videos and in the audio that I send you. They can be fine tuned. Those thresholds can be adapted. And in the case, for example, that Bradley just showed, that has a bunch of tall lines.
Yeah.
That's obviously type of misclassification.
Exactly.
Intelligence to determine that it's noise, because we know that the speech that is detected is too narrow. So that cannot be people just switching voices.
Exactly. And even if we do some type of trimming and particularly focus on those samples, there will be probably less than 1 second. And of course, there's no speech in 1 second that can be analyzed further.
Yeah, I'm segmenting my audio in segments of 250 milliseconds.
Okay.
But that not only adds, that's a lot of time. I mean, that every segment that I analyze takes time. If the segments are longer, they contain a lot of information. I can tell you with a very, very high probability who's there in that segment.
Yeah,
so I want something that is, and it doesn't need to be perfect. It doesn't need to be perfect. I mean, you can have, for example, in the segment that contains the same person, you can have a silence of, let's say, I don't know, 500 milliseconds, and be detected as silence, and then it's fine. It is fine. I just need something that is a little bit more better than this, because all this will be treated as silence and a speech, and it will add timing to my process.
Exactly. No, okay, I understand now. I have one last question. The output or the format that you're actually using that will better fit your pipeline, what is the output that you desire for this?
A text file that contains the data. Well, if it is not possible, fine. If not, WAV files are fine.
So a
Wait.
WAV file that has been
Yeah,
okay, let me say this carefully. Each WAV file will contain only speech.
correct.
So,
Or noise. Okay? Yes.
or noise.
Exactly.
So let's say that we have a 20 or 10 minutes a clip of audio from Aolme,
Mhm.
and then we produce a folder, and inside that folder we will have all the in-WAP files, all of the segments on which we think that there is a speech.
Correct. Let me share my screen.
Okay.
And so I can put here. You see my screen?
Yes.
Yes.
Okay. You see where the cursor is? For example, this will be a segment. In ideally, let's get this is much better, okay? Between this and this is a segment. Okay, between this and this, that can be considered noise. And it will be another segment. From here to here will be another segment. So every single time the voice activity detector see a change, that's a segment.
Awesome. Okay.
That's it.
Yeah, I see. One last thing regarding the WAV files. Are you okay with 16 kilohertz sampling rate?
Well, I have everything on 48 kilohertz because what the cameras, the video cameras have. But I can upsample.
48 kilohertz. Yeah, I mean, it's fine. Those are requirements that are important for the deliverable.
Exactly.
So it can be whatever is required. So 48 kilohertz it is. And each WAV file.
But you see here, I mean, from this point to this point, we all see that this is noise. But you see all the transitions?
Yeah.
This will be interpreted as segments with some information. I want to avoid this because this is a burden that I'm putting to the system trying to detect, which we know that is noise.
If we have a WAV file that is, for example, less than 1 second, it might not have any speech there, so then we can safely discard it, right?
Very likely, or 500 milliseconds. That's something that we can analyze.
Yeah, there's a certain window there that has to be like defined.
Absolutely.
Defined.
That's where the intelligence comes and where the trimming of this program.
Exactly. There is some type of a heuristic there that needs to be fine-tuning. Okay, awesome. I think I understand what you are required, and then after that, I think I can take and help with the group.
Okay.
I believe that this is possible to be delivered by Friday. I don't think it's going to be like that harder, but we have to work every day. So
yeah. We still have time, but I'm running out of time because I need to do the experiments. I've been dedicating this past week just to write a paper and to write a dissertation, 2 things that I'm doing. And
I know. It has to be done. It has to be done before if you're doing on the spring semester, then you're a little bit tight on the deadlines. Yeah. Okay.
Exactly. And I mean, it is a lot of writing that I have to do. And
yes. Yeah, I know the feeling. I remember that. Okay, awesome. I'll take care of that from here and work with Bradley. Don't worry.
Okay, but this will help. I have another assignment would be that, and I was having my son helping me getting the Microsoft Azure cognitive services to do the same thing that my program does, getting an audio file and determine the speaker, identify the speaker, all that kind of stuff. That's another humongous task on its own because we need to put the programs in Python and we need to run the programs and train the networks and all that kind of stuff. And eventually I'm gonna have to do that at one time or another. So he was trying today Microsoft stuff and we sending some of the files over there and see how it responds. And
nice.
I'll see how it goes. But this is something that I need now.
Yeah. I mean, it's definitely doable for Friday, but we have to start working every day. It's okay.
That's it. That's
Tony, may I ask, so we're trying to accommodate your needs as well as our project as well. So as Luis was saying, our thing is due Friday, statement of work, we'll be working on that. But when is your deadline? Is it by end of March?
Well,
or the sooner the better?
I'm supposed to present the dissertation before April 15th.
From New Mexico, is it only the presidents?
I'm sorry. Who's there? Before that day, but I need to finish all the experiments and all the paperwork before that. So
let's say are deliverable from us, and we'll try and work to that deadline.
Okay, that's what I'm let me see if I can give you a decent time so we can have all this in place. you think you can have something for the second week of March, like the Friday 12th of March or something like that?
Yeah, that's the Friday before spring break, March 12th.
Okay.
Luis, is that possible?
Is that
Yes.
possible?
Yes, it is.
Okay.
Yes, it is. But you are going to like listen my voice every day.
Okay.
That's fine.
Okay.
Gotta
Nice.
do it.
Just if you cannot do it, just let me know, and I will accommodate myself to another thing because I have plenty of tasks. And this is another set of experiments that I need to run with the voice activity detector. I have run every single one with the fixed segmentation. Those are done. I need to run this.
I like that idea.
Yeah.
Mhm.
And
Okay.
it's just experiments take time on their own.
Mhm.
So if they're done by the system is done by the 12th, I can run during the weekend, for example. I can do the experiment during the weekend and get that. And again, it doesn't need to be perfect. It's just another way to do it. And I will put it on the paper. This is the way with the voice activity detector, and this is the improvement that we're getting. And I may not get nothing. I mean, probably, I don't know if it's going to be good or bad. But we'll
At
have to
least
try
we'll
it.
be able to find the one that actually works the best. So that will
Exactly.
probably save you some time.
And that's part of the research.
Yeah.
Figuring out, okay, which method is best, because this is a very important piece of any speech recognition system.
Exactly. Those are, I mean, your project is what is going to give us the introduction of
Correct.
why this is important, and that's it. That's all you need in
That's
order to
all.
to defend why what you are doing is relevant or makes sense.
Exactly. I mean, look, this thing doesn't need any voice activity detector, doesn't need anything of what I'm doing on the other side of trying to recognize the speaker or anything like that. This is the preamble of everything. This is how we're gonna pre-treat the audio so it can be the segment have enough information for the system to take care of. And you can do anything. I mean, you don't need anything on my side. You just need audio very well segmented.
Mm-hmm. Yeah,
That's it.
makes sense.
Yeah.
Okay, so for Friday, I believe that we can actually get at least two methods running different type of audios, and at least defining what is the initial baseline. As you said, we don't have a baseline, so we can start working on that in parallel too.
Yeah.
Also, another undergrad can actually take care of how to extract the probabilities and then divide and work with the audio. If you have no experience of Python, this actually will be really helpful. And yeah, we can also work with the one that you already have, the MATLAB,
Mhm.
and we should definitely look at least two more. We can focus on only one more for Friday, and then for March we can get the other one running. Yep.
I seriously don't mind what you use. The only thing that I mind is getting one of the videos,
Mhm.
getting the audio pass through this system,
Mhm.
and getting it segmented at the end. That's
Okay.
all. And that's it.
So what we can start today is that, Kong, my understanding is that you and Bradley were working on this MATLAB, right?
Yes.
Yeah, this morning.
Yes.
Awesome. So what I need you to do is that I will give you some AOLME audios, and you will run those AOLME audios on this MATLAB, and you will run also some clean audios, and that will be our first step comparison.
Okay.
Yeah, okay.
The idea is that the AOLME audios, the dirty audios, will fail miserably, and that's how we start the problem, and that's how we start defining why this is important.
Yeah. For example, you get this audio with a computer in which the speakers are very well defined.
Mhm.
You see very well between computer and between the astronaut. If you can get that audio segmented in very good pieces of both of those two speakers, that's it's an excellent start. Very good. And then you can complicate your problem a little bit more.
Mhm.
Getting into the audios that there is a little more speakers or they are closer together or they start overlapping.
Yeah,
Because overlapping is something that we're gonna have to try to deal with.
that's my problem, Tony. That was a crosstalk that I was trying to solve for my PhD
Yeah.
qualifying exam.
Uh-huh.
with the video, visual audio networks. So-
The fixed segmentation allows you to work a little bit with the overlapping because you're going to have the overlapping as something crazy, some kind of missed classification. But
Mhm.
immediately the segments are small enough, the transition is going to help the next. But that's fixed. I don't want to do that again because I have to segment it in hundreds of files, hundreds.
Mhm.
So we're
So-
talking about that. So sometimes 2 minutes of audio takes 8 hours to be processed. That's unacceptable.
Yeah, of course. Do you have the? Can you give me the proper name for the example that you told me before of the two persons talking, like clean audio? Do you have the name of that so I can look for that on Google?
The one with the computer and the astronaut.
Yeah,
Well,
that's HAL, right?
yeah. That's a clip that I took from a movie. That's,
Oh yeah, 2001: Space Odyssey,
Yes.
classic.
Yeah.
Okay.
That's a prepared. I doctor at audio in the sense that if you go to YouTube, you can see the actual clip there.
Mm-hmm.
So that actual clip, I capture it, I download the audio,
Mm-hmm.
and what I did is manually I separated the computer from the astronaut, and I put that into a stereo track.
Oh,
So the
I
astronaut
see.
is in left channel and the computer is in the right channel, or vice versa, whatever it is.
Mm-hmm.
What am I doing that? And the noise is separate. So I do the noise and I put it in a CD player, in a CD, an actual CD. So here in the lab that I have, I play the computer as one speaker and the astronaut as the other speaker. And the noise is in the background playing on the CD.
Oh, I see.
You see what I'm doing? So that it can be captured by the microphones,
Yeah.
one channel, another channel, and the audio, the noise is all in the ambience, in the atmosphere of the room.
Uh-huh.
And that's what I'm using.
You're replicating the space craft over there.
Exactly. Replicating a space because if I had to play it through two separate server speakers here.
Mm-hmm.
So,
Yeah.
and they are located as there were people sitting at a table.
Mm-hmm.
And then I have
Exactly.
a page for when I have more speakers in the same way, in which I change from speakers 1, 2, 3, and 4, which are located, you can see at the table. You see the speakers?
Mm-hmm.
Well, that simulate person sitting in the table.
Mm-hmm. Yeah.
So the computer talks in one, the astronaut talks in the other one, and when I have more speakers, I just use a switch to switch between 1 and 2, and the noise is always in the background captured by the ambient. It's not going through any particular speaker.
Mm.
It's the atmosphere.
Exactly.
Okay,
It-
so
it
that's the
comes
way. So I
from-
can give you that, but I can send you the audio. I mean, the original audio that I did.
Yeah, I mean that
Okay.
that can be another nice example. So far, I guess just to prove that this thing works, we can use a very simple
Mhm.
HAL. Any audio will actually work that is understood
Yeah.
to be clean.
Yeah.
And then we do the comparison with the AOME audio that hopefully will fail, and then you can start working with that from the failure.
Correct.
Mhm.
Any audio can work. I have another audios. We have no echo whatsoever.
Mm-hmm.
They are plain audios from one university, from I don't know which one it is, and they are male, females, and they are all the statistics and everything. And those I use it as well as speaker 1, speaker 2 that coming from those speakers. Those are complete clean audio from anechoic chambers. So, but I want to have something a little bit more complicated, which is this thing captured from a movie that is not perfect at all. That's
Yeah.
It's noisy, rainy. It has a lot of crap.
I see.
Okay.
Mm-hmm.
And I already have from another student ground truth on that audio on the places that my current segmentation system and current program is failing and is misclassifying things. So I have that already, and this as soon as I put the void activity detector, I will run both of them and see which one does it better.
Yeah.
In what segments are failing, and so
To allow you to prioritize, right? To focus on some audios instead of the others.
yeah, I mean, I need to see exactly what points are having. What is the weak point of my system?
Mm-hmm.
Which at this point, I think is the segmentation. The segmentation is a weak point. very weak,
I see.
right?
Hmm.
For a number of reasons.
I
So
see.
that's what I want. That's what I'm looking for.
Okay, nice. I got it.
Okay.
I have a lot of questions for Bradley and the students. So
Okay.
if you want, you can stay. Otherwise, thank you
Well,
for coming.
I think I'm gonna go now. I'm gonna go and eat because I haven't had my lunch yet, and
Sure.
go back and continue writing.
Yes. Sounds good.
All right.
Okay, thank
Okay.
you, Tony.
Okay. Appreciate it.
Thank you.
Goodbye.
Thanks. Okay. Bye.
Okay, guys. So I have a couple of questions. How many methods do you find so far? You found
For what?
for the audio, for the speech segmentation.
We just have these two programs, these two MATLAB programs. And why are we behind? I don't know. Bad snow, test last week. We just failed to get together consistently.
It's okay. I mean, what is done is done. So we have to move and work with whatever we have. Don't worry. We're not pointing fingers here.
Right.
I just want to be sure how much methods we have. So hopefully we can divide and make two teams. So one team can work in one method, the other team can work in the other method, and they will do exactly the same. Compare clean audio with noise audio. Let me actually jump. Oh, we have 9 minutes. Okay. Is that okay if I share my screen?
Yes.
And I want the whiteboard so we can talk better. I'm sorry, Ahmed, you were saying something.
Yeah, quick thing. Well, the meeting ends in 10 minutes, so we'll just jump back on it again, the same link. Second thing, regarding, so we have this as the project. We just need to understand what is the product scope, what is the product, like, why is this something that we should pursue, all these details before actually jumping into what team and all that.
Okay, so you are okay. I understand your concern. Let me show you some part of the presentation that I did for my qualifying exam, and then hopefully that will give you a little bit more a better understanding of this. Basically, what we're actually looking for here. I'll stop share here. Okay, what we're looking here is whenever you want to do any type of audio processing using either deep learning or any other audio methods like audio separation, speaker identification, speech recognition, bilingual speech recognition, or any other, you are most required to first do a pre-processing on the audio. And that pre-processing is either you find the parts when the people are talking, which is what Tony requires, or you do a cleaning process in which you remove some of the noise in the background. Now, let me share my screen, and I want you to know have you heard some of the AOLME videos that these guys are working on?
Have we what?
AOLME videos, the AOLME videos that they have been working on. Let me show you really quick here.
Tony gave us some, what is it, Liz, sample one. Liz.
Yeah, I mean, really, anything works, really. So here, this is the audio you're actually facing.
This implementation. So now we're going to go to let's do it. Let me see the tool. R32.
That's the audio you're facing, and this project has $1 million on NSF. So they care. They care to understand what the kids are saying. They care to understand whether they are learning or not, and so many other things. So there is so many projects that actually come from this project, and all of them, all of the audio projects, including mine, require some pre-processing. And your project is part of that pre-processing stage where you define when the kids are talking and when not. Another student from the lab, Wenjing, I believe, has this complete study of talking versus no talking just by using the video without listening to any audio. She can tell you if someone is talking or is not talking, even if they're not facing the camera. So to reply, to answer your question of why is this important, why is this commercially available, or whether this is relevant or not. It's relevant in the sense that there are other projects from senior students from the PhD and people that has been like putting money here that are interested in getting either speech recognition or speaker identification, and your part is essential to that because it's a pre-processing stage. And also, if you want to like put in a commercial way, because I understand that the senior project design usually goes with this type of like how we're going to sell this product or like product things or everything. The moment you show this type of audios, the moment you show an audio, for example, from a very noisy coffee shop, looking to listen. The moment you show an audio from a noisy coffee shop or a noisy place, and you are unable to understand if they are talking or not or what they are saying, then that is when your commercial product shines, because you will say this method is looking forward to be a complementary pre-processing method on the pipeline of any already commercially available products that works in the audio processing domain. And that's how you defend yourself.
Okay. The reason I'm asking all these questions is because our priority as the 3 students is to get that document, the statement of work, by Friday. Of course, as well as we agreed with Tony that we're going to be working on his stuff for the following Friday. So my understanding is we're going to be creating a program, regardless whether it's in Python, MATLAB, whatever, that identifies speakers and concatenates their speaking, like their speech, intervals all together and isolates it from all the background noise. And we want to make it as efficient and as good as possible, right? And this will be part of a much bigger project, which is Tony's project, right?
Yes, and this also, okay, I believe that over there you need to throw a couple of references. So there was definitely, I should be working with Bradley to come up with a bunch of reference for you to put on your report to say, given the current research on, and then you start like reference 1, this research from this paper, from these people, from this grant, from these people, they all require audio processing. And what we are trying to do is to come up with a solution with this thing, unconstrained learning. This is how the education department defined this type of environments. For the education part, at least, those are unconstrained learning environments, which means that there's not such thing as a single speaker. There is a lot of cross-talking. There is a lot of noise in the background. None of the speakers actually are there for the recording. They are doing their thing, and then we are recording. So whenever you have this type of things, if you want to go for like the defense thing, then you can go for example, how do you say this word, like vigilancia, or like when they're like recording things for security with security cameras. Surveillance, that's the word. Yes. So that will be the other end. I mean, here, of course, it's completely like open, and if you are an international student, you're happy because you can actually work on this. Surveillance will be more into the Defense Department, and you will need a U.S. citizenship to be part of those projects. But those are the same idea. Unconstrained environments. In this case, is learning. In the other ones, will be other type. So that's what you're actually looking for. If you put this type of audio, this one,
all of the files are going to be under audio.
Into one of the like already like audio speech separation programs, and they fail, then you know that that solution is not suitable for us. You need to come up with a better one. At least pick the one that works the best. So what you have to focus on your report is that you need to like always compare this type of audio in unconstrained learning environments against clean audio from clean data sets of people talking directly to the camera, like a podcast, for example. If you run the program into a podcast, then of course nothing will happen, right? It's done. The problem is dead. Same idea that if you say "Hey Siri" to your phone, that is really next to your face, but if you're in a party and you say "Hey Siri," your phone will never catch you.
So you said you wanted one of the methods to fail in order to show that there's a need for what we're doing. And this is
Exactly.
why
The initial baseline should be basically running this type of audio into one of the methods, maybe 2 or 3, and then failing. And then you say, okay, this is why we need this, because these current methods are not able to catch this type of audio.
All right, sounds good.
Mm-hmm. So what we can actually work with for Friday, apart from your report, don't worry. I mean, I helped like a couple of students before with that report that can be done in one day. You just need to type properly all the references, and then you're fine. I believe that what we can actually get for Friday is we can get at least 2 methods and then compare them, which will be essential for your report. Essential. You need a method with this type of audio that we will provide to you, and then clean audio that you can actually get. The HALP actually works well too, and then
That's where they kind of are. And
Yeah, this has to be completed by Friday. We need a product scope. We need a lot of things and saying that why this is essential, what our project is going to be. We need a plan for the project as well. Like, okay, we're going to pursue voice activity detection. First week or first stage would be identify the 2 methods. This will take 1 week or 2 weeks. Next stage, program something. This will take 3 weeks. And the deliverables that we're going to be delivering next semester, I believe.
Yeah, I mean, in this case, you're kind of like running short because most of the work should have been done in the previous weeks and the previous months. So we have to like run on this one.
Okay.
Mostly to in order to provide Tony what he requires.
Okay.
Because otherwise, if he leaves your project, then you won't have anything to defend. So that's kind of a sad a sad thing to happen.
You know, we just finally figured out these timelines because these guys are like at the very beginning stage of their project and trying to, get an idea of what exactly it is. And then Tony, on the other hand, he wants to graduate in May. And so, we have a very, very small eclipse that, or Venn diagram of these 2 points that meet, So that's kind of what we're working with, but we'll just try to do our best with this timeline.
Oh, we'll actually make it. I'm pretty sure you can make it. We just need to start dividing groups right now.
Yeah.
You can actually get on your report to whatever we have discussed today. I believe that you work as a team, right? So you all 3 have to present one single document, right?
Yeah.
That's how it works.
Okay, nice. How many documents you have to present? 4, I believe.
No, it's one statement of work. So one massive Word document. And I'm not sure if there's a presenter. We need to make a PowerPoint out of that Word document, but we need to present that Word document to the class and say this is what we're doing and stuff. And I was going to tell you that I was going to work on the statement of work tonight, and I was going to fill in the stuff that I understand, and I'll send it on the group for whoever to check, and then we can go from there.
Yeah.
Put it on Discord, Luis.
Yeah.
Okay.
Okay, I will download Discord. One wrap.
Okay. Tony's on it too, so that's good.
Yeah. Okay. Okay. So, Kong, can you download the AOME audios and the clean audios and make a nice comparison with the graphics for tonight?
I did I need where to download it.
I'm sorry, what?
Yeah, where do you download it at?
Yeah.
Where?
Yeah.
I mean, I believe that Tony gave you the audio, right? The lease audio from Aolmi.
Okay, I think what Luis is saying is in our UNM accounts and on a OneDrive. In our UNM student accounts.
Okay, well, Kong, can you look into that like sometime in the next few hours and then text Luis where to find it? Like communicate with him, try looking in the OneDrive and then message us what you found.
Yeah, I'm looking there right now.
Alright, perfect.
Let's see what I can find.
Okay, that shouldn't take like more than 10 or 15 minutes to find the audio. Set it in the proper format, and then run your code that you already have running in both audios. And then we need those plots to start working. And that will leave Tran. Is that okay? Did I say the name right? I'm sorry.
Yes.
Awesome. Nice. So that will leave you with the task of finding another method. And I will strongly recommend you to go deep learning because everybody loves deep learning. The moment you put deep learning on your report, then you know that you are actually doing something that is cutting edge, that people care about. Because if you want to get a job, they will ask you to learn about deep learning. So this deep learning is the way to go. I'm sorry.
Okay.
So that will let you find a different method from the one that they already have working on MATLAB that we can start working. Ahmed, once you finish the report, you need to start joining up with actually finding the other with this other method, probably in deep learning. So you have to learn Python. Do you guys know Python?
I know a bit.
I've done Python before. I have to brush up on it, but I've never done deep learning or PyTorch.
Oh yeah, that's exactly what Mario wants, and that's exactly what will take several hours of your life for the next weeks, because you have to set up the environment. And I will help you with that because I'm very familiar with doing those setups. So we will start working on that tomorrow morning. But for tonight, we need a method and we need the document to give a first draft for tomorrow. Because that document needs to be rewritten at least 3 times. So then we need the first one for Monday, next one for Wednesday, and the final one for Friday.
Okay, for Thursday for approval by Marius, right?
Exactly, yeah. That document will have to be rewritten, so don't worry. Don't spend that much time on it trying to find the perfect words because we're going to check that thing, so it's okay.
Yeah,
but we need a first draft, a first complete draft for that. So guys, are you understand what you have to do for tonight?
Mm-hmm.
I do.
Nice. So we will meet tomorrow again. What time is that? Is that okay for you? Just 10 or 15 minutes. That shouldn't be more than that.
I am free from the morning, let's say 8 or 9 up until 11.
Mm-hmm.
Yeah, actually, I'm virtually free from 8 or 9 till 2.
Until 2 p.m.
Yeah.
Okay. Yeah, then you can meet at 1. Is that okay?
Yeah, that's okay for me.
Awesome. Okay, then we'll see you at 1. And Bradley, add me on the Discord.
Hang on, Luis. I'll send you an invite link right now, and you could just join.
Okay, I've used Discord before, but honestly,
Yeah,
never came back to it. It doesn't matter. That's an off topic. So I saw my last thing is, Bradley, I saw your results and I have a question regarding that. Let me pull up the figures here. So there is one nice figure that is called Deb. I will share my screen right now. Hold on.
Yeah.
Can you allow me to share the screen? I will download this code.
There you go.
Okay, so this one, it's from which audio?
That's from it's from the HAL audio, you see?
The HAL audio. Okay, got it. And
And
what about this one?
Okay, that's the
Same.
HAL audio also. The difference between the two are the programs. You see, this is a voice activity detector. That's VAD. That's one of the MATLAB programs.
Okay.
This one is the other one. Go to the other one.
This one?
No, the next one.
There's no next one.
Yeah.
There's only two.
No. Just go back one, right there. Stop. Up. No, right there. See, this one MATLAB program is called Detect Voice Example,
X-HAL.
something like that.
Okay.
They're both in the Discord chat, and there I put them on Slack also. But
I'm
those-
pulling them from Slack. Yes.
Yeah, those are the two audio programs, two MATLAB programs that Tony gave us.
Okay.
And
That one is the first MATLAB program, and this is the second MATLAB program.
right, I got the previous one to work a few weeks ago.
This
Yeah.
one.
Yeah, and I didn't know what to do with it. Okay, Tony, we did it. The yellow is the signal,
Yes, of
the
course.
blue is the noise.
Mm-hmm.
And that's like the end of the HAL episode right there.
Okay.
This
And what about this one?
Now, I think what Tony was describing is that the yellow is once again the signal, and the blue is the noise.
No, the blue is the signal. There is clearly the yellow is dividing which part segments
Okay,
the signal is.
That's what I was going to say next, because that's what Tony described.
Yeah, I mean it's clear.
Yeah, so it's the opposite. The blue is the signal, and the yellow is the noise in this one.
Okay, so Bradley, I need you to run this audio in this method and this audio in this method, so you
Yeah.
can compare them and choose which one you are going to use for the final comparisons. Okay?
Okay, I see. These are like two different programs, two different methods, right?
Yes, exactly.
Okay.
You are telling me this because I'm asking you.
What's that?
I'm asking you. Those are two different methods, right?
Right. That's what Tony gave us. He gave us two different audio voice detectors.
Okay, awesome. So I need these two audios to be run in these two different methods, which means 4 figures.
Okay.
Okay?
What's the audio file that you want us to run?
The same ones, these
He
same
wants-
audios.
Brad, you've got two methods, two MATLAB programs which do the voice activity detection in two different ways, and you've got two audio files. So he wants each audio file to be run in both methods. So he
Okay.
wants 4 outputs
Okay.
in order to compare which method is better and stuff.
Exactly.
Okay.
Yeah.
I've got like, I don't know, 5 different audio files, okay?
Fine. We're going to stick to the ones that are there on the figures. We're not going to look for further on that, at least for today.
Okay.
Awesome. So we're all set.
All right.
Louis, question. So you want us to find, Anna and I, you want us to find another method that does voice activity detection, another program on the internet?
Yes, it has to be really available, and I will actually give you right away a couple of suggestions. Hold on. You may actually want to check for this part. Papers with code. This is a very nice.
Yeah, I found that.
And this one is mostly deep learning, so TDT detector.
Any language, right? Or specifically MATLAB?
If you can work Python, then work on Python. If you want to stick on MATLAB, probably what you will find here will be Python. So I will have to say that you have no escape. You have to run in Python.
Yeah, I'd rather have Python.
Yeah, so you don't have much of a choice there. Just make sure that whatever method you find, you're actually able to grab the code. And this is a nice place to start. You can also like get into Medium or Towards Data Science, which is a classic website. And there, oh, give me a second.
Okay, Anna, you got that?
Hello. Hello. Okay, sorry guys, got a phone call. So make sure that whatever the method that you find, it's actually widely used, and it has a repository on GitHub, which is actually very important because you will basically download the code and run it yourself.
Okay.
If you have a commercially available method that you have to pay, you can also include that as part of your references. So don't ignore them either.
Wait, say that again.
Don't ignore the the commercial solutions.
What do you mean by commercial solutions?
If you find a software that actually does what we are required, but they
Uh-huh.
require you to pay, that's a commercial solution.
Okay. Step that in
And
the references.
yes, that goes to the references. Mhm.
Okay.
You
Alright.
might not be able to use the code because, of course, you have to pay to actually use the software,
Yeah.
and that's okay. That's fine. Just add it to the reference.
Okay.
So right now, for your report, you will have to like get at least 3 or 4 methods that actually already is doing that. But the one you will pick to work will be the one that allows you to download the code and work with it.
Okay.
And what I'm telling about deep learning is not that it has to be deep learning, but I'm thinking that it's very, very probable that it will be deep learning, given that the nowadays explosion of deep learning, everybody wants to do deep learning.
Okay. And if we found like Python code on our website that you were showing, and you said it already works, our project would be to make it work better somehow.
Exactly. Your project will be to like fine tune that solution in order to work with unconstrained environments.
Uh-huh. Okay. Alright, that sounds good. I know I'm doing for tonight, and I'll just send it tonight.
Nice. I think you can. I think, guys, you can actually make it for Friday. That's not impossible. You can actually get something working on the code and get the report done for Friday. So you can still save everything.
Can I
Okay.
share my screen for a minute?
Sure.
Go for it.
Funny thing, I can't stop sharing.
Oh, brother.
Oh no. Okay. What you want to share, Bradley?
Okay, here's my UNM account,
Okay.
and here's OneDrive.
Yeah.
I've got the under my files.
Mm-hmm.
This is what Luis gave me a long time ago,
Yeah, but I mean,
November 27th. Okay.
why you need that?
Well, maybe we don't. But you see this one video samples? This is the one from Tony.
Okay, hold on. I can't see anything because I haven't stopped sharing my screen.
Oh.
Yeah, that's really bad. But
Okay.
hey, Bradley, tell me, why do you need that?
Well, maybe we don't need the OneDrive. Okay.
Yeah, maybe we don't. So don't worry. Just focus on what we were discussing.
But there's this thing called video samples. And it's a zip folder, and I'm uploading it right now. You can see the thing spinning. So look for that in your OneDrive.
Okay.
Brad and Kong, do you guys know where to find the Almy audio files that Luis was talking about?
Wait.
Is it in this video samples?
Brad, hang on. I don't think Luis can see, so let me stop sharing for everyone, and then I'll let it back again. Is that all right?
Okay. Yeah. Share screen.
Go for it.
Here we go.
Luis, are you good? Can you see?
Yeah, I came back. Tell me.
I think this is the only thing that's in this. It's the HAL, and the 2 Liz sample.
Nice.
So
But they're in this video samples thing, it's called. Right?
Okay. I mean, that's your part. I'm not going to go down and debug every single line of the code. I don't have the time for that. But
No, Luis, I'm not sure if they know where to find the 2 audio or the audio files that you were talking about, the Almy ones. You
yeah.
told them from your UNM account, but I don't think they know.
Okay, the AOLME ones should be that ones, List 1 and List 2. Those are videos, and those has the audio there. So you have to write a Python code or an FFmpeg to extract the audio from those videos. Hello?
yeah, I can hear you.
Okay. Yeah, it's just an FFmpeg program, simple, to just extract the audio from a video and save it as a WAV file with 48 kilohertz of sampling rate.
So Luis, just to make sure, my job tonight is looking to find the audio file for us, right?
No. Okay, you need both audio files, and then you need to run them with Bradley on the 2 methods that you showed me on MATLAB. So you will output 4 different figures.
Okay.
and then we will see if the audio, if the method actually works better with clean audio or with noisy audio. The noisy audio is the Olme.
Okay.
Mm-hmm.
Okay. Kong,
So-
maybe we can meet and do this online.
I'm sorry, what?
Kong and I, we can meet online and do this.
Yeah, sure. I mean, just get the FFmpeg proper command for the terminal in order to extract the audio from there, and that's it. And check on your MATLAB and see which audios you work, because you work with those audios, so you know them.
Okay.
Brad and Con, do you guys understand those Liz2 files, Liz sample 1 and Liz sample 2? You got to extract the audio from that using Python or some code that he was talking about, as well as get the 4 outputs using the 2 audio files that you used this morning.
Okay. I mean, we could use Audacity or something like that, right? An Audacity
Whatever
program.
you want, man. That's up to you. Whatever you want. Just make sure that it works, and that, of course, that it actually it's up to the requirements, which means have to be now a WAP file of 48 kilohertz, as Tony said before.
Okay. I mean, I know Audacity. We can get the audio from the video.
It's up to you, Bradley. Don't worry.
Okay.
You can get pick the tool that you best use. That you
Okay.
best know
But
how
the
to
two
use.
programs, they only produce like two outputs each, right?
Man, that's the MATLAB code that you just run in the morning. So
Right.
that's up
Right.
to you again.
So for each file, yeah, two are whatever outputted.
Mhm.
So
Okay, I think we're done here. I need to jump to another meeting. So
Okay, yeah. Thank you very much, Luis. Appreciate
mhm.
yeah.
I'll see you tomorrow.
But when do you want to meet again, Luis?
it. 1 p.m. tomorrow.
1 p.m. tomorrow.
Okay, on the same Discord link.
Yeah.
We will see. We are now in touch in Slack, so don't worry about it.
Okay, we could do that too.
Yeah, don't worry.
Okay.
All
Okay,
right.
guys. Best
See
of
you
luck
guys.
and work very hard. Bye bye.
Okay, bye now. Well, let's see. I guess Ahmed, you're going to work on that paper, right?
Yeah, I'm gonna try and do as much as possible from that statement of work, for as far as I understand, and then I'll
Right.
help on find another method.
Okay.
Do you know how to find another method? He showed us a website.
Yeah, I need to know the website.
I'm not sure of the website name, but I think I could put it up and I could send it to you. But if you search on Google voice activity detection, plenty of websites will come up with plenty of
Yeah.
methods. So
Okay.
yeah, let me know if you need my help with that, and I'll let you know as soon as I'm done to help you. And
Okay.
Kong and Brad, you guys good?
I mean, I run the programs, right, on these.
Yeah, you have
Audio
2
files.
tasks. The programs that you ran this morning with the 2 audio files that you ran, the
Right.
ones that you have, we
Oh.
need to swap those audios with the programs and get
No.
2 more outputs.
Let me clarify one thing.
Okay,
2 programs we run this morning is only 1 audio file.
right.
So now we need 1 more audio file for those programs, not swapping it. Okay.
Right. He's saying one program output one audio file, one picture.
I thought you guys said you had 2 programs and 2 audio files.
Yeah, one audio file for each. You know,
We
one
never
goes to
say
one,
2 audio.
the other one goes to one.
Wait, so you guys have 2 audio files and 2 programs, right?
Yeah,
Okay, so
One-
you're gonna do each audio file with each program. So
Wait, no.
audio,
2 audio file, you say, is it the same audio? The one in the really show you that the audio, something like that. This is on one audio file. So now
Yeah.
we need to figure out 1 more audio file and run
so you
the
don't
RAM
have 2
again.
sample audios, you only have 1 sample audio.
Yeah, only 1 sample audio for now.
Okay, yeah, I thought you.
no,
Yeah,
we've got Liz 1 and Liz 2. We could do the same thing.
yeah.
Yeah,
Well, Yeah.
We do the same thing here. We did this one.
Mhm,
We did
yeah.
this one. We could do this one, and we could do this one.
Yeah, I think Luis has the understanding that you guys have two audio files, but in that case, just do Liz 1, Liz 2, take the audio files out of the video, and
Yeah.
then run them through the two programs in order to get 4 outputs,
Right.
Mhm.
and then you're sorted.
Then we're good. Okay.
Yeah,
All right.
and we'll
All right.
talk on Discord tonight for progress.
Okay. All right.
All right.
I think I could try this, running the files. Okay.
Okay. Sounds
And
good.
if Kong, you want to look for the other internet thing or something like that. Okay.
Okay, okay. I will try to find.
Okay. I'll try to do it. If I need some help, I'll Discord. Okay.
Okay. Lovely.
Contact you by Discord. And then you're good with Ahmed, I guess,
Yes.
right?
Okay.
Okay.
See you guys.
Okay. All right. All right. We'll see you guys. Well, definitely tomorrow at 1 p.m. Okay.
So do I have to finish finding the another method by tonight?
Yeah.
Okay.
It shouldn't take too long. It should probably take maximum an hour. There are plenty of methods. As long as you can download the code and run the code to produce something, then yeah, you're good.
Okay.
Okay.
All right.
And I'll stick with Kong if I need to call him or anything on Discord. Okay.
Yeah, okay.
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 See ya.
I guess that's it, you guys. All right. See you tomorrow at 1.
See
See you.
ya.
Okay. Bye now.